Hey guys, welcome back to another super boring video. This time I'm gonna explain every single part of my rule-over machine using physics terms. So let's get on with the video. So at the start of the machine, I'm using wheels and axles and inclined planes since I'm using a marble and a pipe to start the action. Then the fourth and fifth steps is basically the same because the marble is still in use and I added another inclined plane. Afterwards, the 6th, 7th, and 8th steps included wheels and axles and lever. Because I'm still using the marble and books are counted as levers. Then, the 9th step is when the large book hit the last large book, which is still using the simple machine lever. For the 10th and 11th step, it's when the large book hit the measuring ruler. So it's still using the simple machine lever. For the 12th and 13th step, it's when pulley and lever plays a major role. The measuring ruler pulls the heavy object down, which is using pulley, and the lever goes down. Last but not least is the 14th and 15th step. It is still using the simple machine pulley because the rope goes down and stick onto the magnet. For the 15 steps of my rule-over machine, the GPE of the first 5 steps is just moving downwards. This is because the marble is moving severely down towards the staircase to the floor. Then the GPE from 6 to 9 step is the same, it's 0, because the dominoes is on the ground. Then at the 10th step, the GPE moves intensely upwards, because the measuring ruler transfers the GPE upwards to the closet. Then, every activity is up onto the closet, so the GPE stays the same. Afterwards, the lever moves the rope downwards and stick onto the magnet, so the GPE goes down. Kinetic and thermal energy are moving higher at first, because collision and movements are more intense during the first 5 steps. The 10th step, both of them move higher because they encountered another huge movement. For change in direction, the marble goes down the pipe with a 180 force. Then it changes into a 135 force as it hits the pipe. Moving on, the force changes into 90 degrees as the marble hits the ground. At last, the force is changing into a 180 again because the heavy object is moving straight down. For friction, the marble is rolling down the ramp too fast because the lack of friction. In order to solve this problem, I added paper obstacles to slow the movement down. Moving on to air resistance. As you can see, it is a fail at first. Because the larger books has more air resistance, so the smaller books couldn't move it. So I added a heavy object onto the small books. Then it will be able to move the large books with enough force. Finally, it's the calculation time, so in my practice vlog, I used a marble to calculate force, but I changed it into a vertically falling object because I think it's easier to predict and measure. So after measuring, the heavy object is 0.1 kilogram and its speed is 0.1 second. As we all know, 0.1 kilograms equals 1 newtons. So you times it all together and include 9.8 equals 0.98. Here comes pressure. So I figured out the heavy object's area is 0.09 using Mr. Alexander's calculations. And from previous answers, we know 0.98 is the force of the heavy object. So we divided it and the answer is 10.88888888. It's basically infinity, so I just not included it. Yay. At last, it's work done. So this time I'm still using the old method, but it's improved. So the distance from ball to dominoes is still 5 centimeters. And after looking at Mr. Alexander's comment, I changed the force into 0.049 newtons. And as we all know, 5 centimeters equals 0.05 meters. So we times it together and the answer is 0.00245 joules.